How y'all doing? Yeah, yeah. I was always under the, I was always kind of under the impression that like New York was like, the city that never sleeps and all that. You ever been to Manhattan at like 10 o'clock at night? Like not like Midtown Manhattan, Times Square and all that, but I mean like the financial district. Place is dead. Really dead. I was shocked first time I did that. Everybody cool? You can see this. The projector string got kicked a little bit, so I just want to make sure we're all good there. Yeah? All right. Enough stalling. Let's get going. This is me, for anybody who cares. Probably the most critical thing you need to know about me is I probably know the least about in-service bus of everybody in this room. I spend a lot of time in the .NET world, in the Java world, in the JavaScript world, a little bit in the Ruby world. I tend to be something of a technology dilettante. I play with lots of different things. I think the other less politically approved term is technology whore. I pretty much play with anything, right? Especially if you pay me. And the other thing is I'm sick, so occasionally I'll be coughing. The interesting thing, I was working with a client not too long ago, and one of the conversations came up as around what is the current status of web architecture, right? What exactly are we trying to do to build things? Because this was around the inevitable discussion around things like Web 2.0. Is it all about SignalR? Is it all about trying to create APIs, etc.? And inevitably, conversations around things like REST began to emerge, and we got into a really interesting conversation such that I really believe that the goals of what we're trying to accomplish, the whole notion of what web architecture really means, has fundamentally changed from where it was like 5 or 10 years ago. I'm not going to call it Web 2.0 because that would imply that we're just trying to incrementally do the same thing better, differently, faster, however you want to think about it. I think we're in the midst of something of a sea change that drives us towards something that's completely different. And one of the great truisms of our time is that if you really want to understand where you're going, it helps to understand where you've been. More importantly, where exactly you were trying to get in the first place. And so, thought it would be helpful, particularly for some of the young'uns in the room who didn't necessarily live through some of this stuff, right? If you just, graduated college a couple of years ago and you were convinced that, yeah, Chrome as a browser has always existed, right? When did Google not have a browser? What do you mean they used to not be Chrome? They thought it would be kind of good for us to go through a little bit of a history first. Stage one was actually this project called Xanadu. How many people have heard of this? Yeah, the rest of you are like, what? I always thought that was a really bad movie from like 1980. And as a matter of fact, if you do a Google search, the movie with Olivia Newton-John is the first hit. You're not feeling lucky though. If you go click on it and it takes you to websites where that contain the Xanadu trailer, it is everything that we tried to forget about the 1980s. It was actually trying to be a musical. I don't know if anybody remembered that. Roller skates, disco, yeah, wasn't pretty. There's this guy by the name of Ted Nelson. This was his brainchild. And it was really kind of interesting. Wired did a complete whole article. I got a quote up from them on the next slide. They did this whole like 6-7 page article. You can still read it up on the wired.com website. Xanadu, the goal here was to create a word processor capable of storing multiple versions, displaying the differences between the versions. On top of this basic idea, wanted to facilitate non-sequential writing. Nelson had this idea that it was somehow constrictive, it was somehow restrictive to actually be forced to read a document from front to back. He wanted to give you the ability to jump around to any point in the document that you wanted to go to. And on top of that, I mean, you can sort of see where the whole modern hypermedia thing starts to kick in here, right? I want to be able to click on a word or click on a tag at some point and jump off to this other location and so on and so forth. Salon had some pretty interesting, strong statements. The longest running vaporware story in the history of the computer industry. It started in the mid-60s was when he really starts thinking about, now imagine for just a moment, trying to program a web browser on like 64K of RAM. Okay, because that, I mean, and that was like the mid-70s. We start talking about PCs. So it was a very audacious idea. Meant to be, check this out, a universal library, a worldwide hypertext publishing tool, a system to resolve copyright disputes, a meritocratic forum for discussion and debate. By putting all of this information within reach of all people, Xanadu was meant to eliminate scientific ignorance and cure political misunderstandings on the very hackerish assumption that global catastrophes are caused by ignorance, stupidity, and communication failures. Xanadu was supposed to save the world. Bring that to your next Agile stand-up meeting as a backlog item. Yeah, by the way, as a user of this software, I want to save the world. To say that Nelson dreamt big is really an understatement, probably the understatement of our industry. But there were a number of interesting ideas, interesting concepts as a part of Xanadu. Server is uniquely and securely identified. Server can be operated independently or in a network. We start to see a lot of the makings of what we'll later call HTTP and HTML and so forth. But it's important to note that Xanadu is largely seen by a large number of people as kind of the genesis. When Tim Berners-Lee was starting to think about HTML and HTTP, there were a lot of these ideas that he was reaching back towards. This has been sort of at the center of what the web was trying to accomplish for a very long time. Every user can search, retrieve, create, and store documents. Well, I mean, create is pretty straightforward, file new HTML, retrieve, HTTP get, store, we kind of sort of, Dropbox maybe, search, well, Google gives us that. Every document can consist of any number of parts, each of which may be of any data type. We kind of get that with HTML. Contain links of any type, including virtual copies, what Nelson called transclusions, to any other document in the system accessible to its owner. These are kind of like hyperlinks, except Nelson always assumed that this transclusion would go and grab that portion of the other document and embed it locally. Because part of the other thing that was supposed to do is it was supposed to allow you to be able to charge for portions of your content. So you could put like a half-penny charge on that little bit that was transcluded. Permission to link to a document is explicitly granted by the act of publication. Each document can contain a royalty mechanism, right? That would be kind of cool, because then we could do all those link shorteners and you could rickroll people into getting rich, right? That would be awesome. Each document, uniquely and securely identified, has secure access controls. You can kind of see how they were trying to, or how, depending on how you want to look at it, how the modern web is trying to bring a lot of these elements into everybody's living room. And to some degree, we certainly have accomplished that. I mean, please name for me somebody that you know who doesn't have a web browser somewhere in their life. As a matter of fact, I was having this conversation with a couple of people I know back home, and one guy says, yeah, there's probably some farmer out there in the middle of the Midwest who doesn't have a web browser. Okay, my mother's family hails from 150 miles south of Chicago. My uncle was a working farmer. My cousin is a working farmer. I was out visiting not too long ago, I think it was 2 years ago. He took, my uncle, who has, he likes to show off his toys too, took me to a tractor that he uses. By the way, the wheels are taller than me, this tractor, so this is a big piece of hardware. Takes me up into the cockpit. I swear to you, an F-14 is easier to drive than this tractor. There are video displays running up the sides of the cab. He's got like 14 heads-up displays down here across, and then the steering wheel, right? And he's like, oh, this is great. I just put it in the corner of the field, push a button, and then I read the whole time. And the tractor drives itself. So yeah, even farmers in the Midwest have a web browser because that was one of the tools. There was a console there that had an embedded web browser using the satellite uplink to go, I don't know, read Dilbert or something, right? This stuff has permeated to a large degree every aspect of our lives. But this was stage one. Stage two was the simple web browser. This is where Tim and his crew gets involved, right? And this was the era of the static HTML page. Anybody remember GeoCities, right? MySpace, the ancient predecessor to Facebook, right? As a matter of fact, how many people remember the movie Space Jam, right? Michael Jordan and Bugs Bunny, and it was like, do you know the Space Jam website is still online? Seriously, you want to talk about a blast from the past? Folks, if you weren't around when this stuff was cool, there was a time when this stuff was cool, right? I mean, this is a perfect microcosm of what the web was back in, what was that, the mid-90s or whatnot? Go away, Dropbox. So we've got, you know, let's check out the press box shuttle, right? No Space Jam news at the moment. Yeah, because that movie is like 20 some odd years out of date. Lunar, oh, check out the frames. Did you see the frames there, right? Isn't that cool, right? I'm sure if I click on a couple more links, we're going to see Blink Tag, right? And, oh, remember when it was really cool to embed like a WAV file on the page so that the music started as soon as you hit the page? There probably is one here, and my browser's like, what the fuck is that? I'm not playing that. No, bad idea. Very, very bad idea. This stuff was the pinnacle of what we were doing in the early days. And this was the era of home pages. And this was the era of, if you wanted to change, if you wanted dynamic content, you went in and you edited the file, hit save, and then the next person who browsed to it got whatever it was that you had displayed. And that was useful, that was fun. But then people started saying, you know, it'd be kind of cool if I like knew how many people actually came to my page, right? You wanted the page count in the corner, right? 47,000 views. It was like the ancient predecessor to the like button, right? And so how do we do that? Well, let's set up, because you know you've got these web servers who are going to receive these HTTP requests. Let's just put like a really simple image in there that when it hits actually executes a small bit of server-side something executable, which will increment a counter and return that value or return that GIF or what have you. And we started doing some simple programming after that, right? Temperature conversion, if you wanted to get to server-side environment variables. This is the era of the CGI script, right? Now, as we started working with more of this stuff, then somebody said, well, shoot, if you can execute on the server, why can't you take that hit counter and put it into a database? And so people said, well, because Bash is a nice scripting language and Perl is, well, Perl was never a nice language, period. But I want to actually do something that's a little bit more powerful, a little bit more real-world programming-ish. So the web servers started building native extension APIs, right? ISAPI was the Internet Information Server API. NSAPI was the Netscape Server API, right? When O'Reilly had a web server, they, believe it or not, a book publisher decided to create a web server because that was Tim O'Reilly's Web 2.0 back in those days, right? Web servers, this is how you make money. We really believed that for a while, by the way. We started creating these things to allow you to execute on the server. And of course, at the time, we said, oh, let's do it in C++, because you know, real programmers won't let their code crash and take down like the whole web server. Real programmers would never do that, you know. Anyway, the fact that none of you laughed at that joke is telling. And then we started to say, well, it would be, the server-side execution thing is kind of cool, but it would be better if we started doing more of this stuff in the browser itself. We like HTML, But actually, there was a time during the late 90s when JavaScript was looked very, very unfavorably. I remember sitting in meetings with various folks at Pacific Bell at the time and being told point blank that JavaScript was a security hole. That if we couldn't require people to have JavaScript enabled, and so we had to have a little bit more control over what was going on inside the browser. And this was when the applet came along. This was when Flash really started to gain a lot of its traction within the industry. Microsoft would, in traditional Microsoft fashion, come to this game like way too late when they released Silverlight. But this was the idea that HTML is nice, but having like fine pixel level control over what goes on in the browser is better. So built all of these, client-side technologies that would reside in the browser, but the server was still relatively simplistic. Well, that was interesting probably for about 5 minutes. Because the Java applet thing then all of a sudden got into the, okay, now I want it to look the same across all platforms, but I don't want it to look sucky across all platforms. This whole applet thing is terrible. I don't want to do that. The whole, we need to keep this to be HTML pure, no JavaScript. Oh, these applets, this Flash, it's all something that users have to download, right? Activex, that was Microsoft's first attempt in this space. We all knew that Activex was going to work because it was C++ programmers now writing things that would never crash in the browser, right? And then people realize, wow, if I can execute native code, I can execute native code. I can do whatever the hell I want. Oh, that's never going to be a security hole. That's never going to be a problem. So we went back again to the server and said, all right, yeah, what we really want to do is emit just HTML. And this was where the Java guys went and bit really, really hard. The whole Java thing, applets kind of started, but where Java guys went almost immediately was back to the server. Sun wrote a web server in Java called Jeeves, but they, of course, had to have that plugin API, right? That ISAPI, NSAPI equivalent. They wrote one in Java, called it a servlet. All the Java guys went, yeah, we want more of those. Sun created a Spec. Sun went off. Is that thunder? God trying to tell me that I got that story wrong. And we saw sort of this breakdown between servlets and JSPs, Java server pages, in much the same way that we do like, ASP.NET, model view controller, all of this stuff started to emerge as to how we break out the way in which we think about code on the server. The whole model view controller pattern, which was, by the way, originally a Smalltalk pattern, and was originally more geared towards things like Excel than it was the web. The idea that you could have multiple simultaneous views of the same model coordinated by a controller. When we adapted it to the web, we really bastardized it to the point where people who have never actually written Smalltalk code or any sort of GUI code don't really know what MVC really is. You're just playing with a very pale imitation of what MVC really started out as being. And then, as we started getting this server to emit all of this complex HTML, people said, yeah, but your website sucks, man. You've got all this data. What is? Oh. All right. We're going to get a room, I think, that's good, because that was just screaming my hair back there. No, seriously, try, guys, you just don't know. Try putting a headset on with a ponytail. Seriously, this is not easy. Is this on? There we go. All right. So people said, hey, this HTML stuff is great. I really want to see us get access to your data. Your website is meh. Okay, you're a programmer. Your website sucks. Guys, I hate to tell you that, but it's true. We are the same people that invented the blink tag. We should never be allowed to do anything that consumers can actually see. All right? And so people said, I want to have access, I don't want you to, produce something that I look at. Just give me the data. Just give me the thing that I really care about. Or in some cases, what I wanted to do is I wanted my website to aggregate several other websites, right? This is when people started talking about portals and whatnot, particularly because HTTP has this really, really powerful ability, which is to say it knows how to punch through firewalls. It's a wonderful, amazing thing, right? No other protocol actually can punch through a firewall because no other protocol can actually be configured in such a way that it will work across a firewall because system administrators know not to open any port except port 80. Because that's safer that way, because attackers will never figure out that port 80 is the only thing that's open and tunnel all of their attacks across port 80. They would never do that. This is how we secure our system. This was how SOAP was born. Don Box, a couple of guys from Microsoft, a couple of guys from IBM, they got drunk one night and said, no, seriously, I worked for Don at Developmentor. This is the story. They got drunk one night, and Don said, hey, wouldn't it be cool if we could like totally replicate a remote call but over HTTP? That would be like awesome. You could do like Corba, but over HTTP. Like go right through the firewall. That would be so awesome. Yeah, I would. Yeah, man. It was, yeah. Wait. We could do this. We could totally do this. Here, give me that cocktail napkin. We're going to write a spec. And that became the SOAP 1.0 spec. Seriously, there were three official copies of the SOAP specification. One lived on the IBM site, one lived on the Microsoft site, and one lived on a server running underneath Don Box's desk. Okay, that was the original SOAP spec. And you know, it was actually a really, really cool idea because everybody who ever tried to do Corba or distributed comm knew that the biggest impediment to success was not reference counting in COM or reference counting in Corba. It was getting the damn administrator to open up the ports to allow the whole thing to work in the first place. You need to open up the ports before my server can start, you know, just consuming memory at a rapid pace, and then I have to reboot it because I never actually figured out how reference counting works. Okay. So we want to have all these APIs. We want to have the ability to punch through these firewalls, et cetera. That's great. But at the same time, something else starts to happen. We start to see the rise of all of these different mobile clients. Yeah. Everybody's got the browser, and everybody's got different flavors of the browser. We've got IE, we've got Chrome. Well, Chrome kind of sort of emerges at this point. We've got Firefox. Of course, Apple has Safari. There's Opera. There's Lynx. If anybody actually wants to look at a text-only web browser on the Unix world, you know, there's occasionally people come to me and say, how do I build a Lynx-compatible website? Go away, man. Just shoot. Get out of here. And so what people started to do is they started to work towards this idea of creating web APIs. Let's just punt entirely on the idea of user interface. Let's just go directly to the data. And they really started saying, well, and this is actually what, you know, the original guy, right, the original REST guy, this is what he was really working towards. This is what he was really trying to accomplish, is this idea that we have resources, representations, we have state, you know, all of that good stuff, right? Even though they never read Fielding's thesis, this is what REST really stood for. And that was kind of where we are up until now, right? If you start talking to a bunch of people in the industry, you start seeing them talking about web APIs, right? If you're building web APIs, you are building web 3.0 or 4.0 or, you know, 4.1.5.2312 service pack 4 or whatever we're calling the web today, okay? There are definitely a bunch of problems, though, with the web as we see it today. Number one, link rot, probably the biggest problem. Somebody actually conducted a survey where they automatically scraped a bunch of web pages and determined that something like 20% of all the links on the internet lead to 404s. because a link is entirely a one-way thing, and we have no capacity to actually reach back to the server. Well, we kind of do. You can kind of say that, yeah, this content is not there, but nobody ever does anything with it, right? It's not like the server says, oh, you clicked on that link, the browser gets a 404, but nobody goes back to the originating document to say, yeah, by the way, that link was bad, so you should like flag it or put a red exclamation point or something underneath it to indicate it's a bad link, all of that stuff. We could, nobody bothers, because links are so cheap and easy. And I remember back in the day when people said, oh, well, what you really should do is you should link directly to the document that you're looking for, directly to the data, and then everyone said, no, go to shallow links. And then everyone said, no, you need to do, meaningful links. No, don't go opaque links. Everybody has changed their mind like 5 times as to how we build these things. There's certainly no concept of a universal identity system. OAuth kind of, sort of wants to get us there. There's definitely no redundancy, right? Unless you pay for it from a provider that gives it to you or you stand it up yourself. And remember that the original goal for all of this, the original intent, and Tim Berners-Lee kind of sort of hedges around this, but Roy Fielding is adamant. REST is about distributed hypermedia, the end. If you are not doing distributed hypermedia, Fielding has made this so clear on so many occasions, he has gotten tired of repeating this, that he doesn't even answer the question when people ask him anymore. It is about distributed hypermedia. If you are not delivering your resource representation in a distributed hypermedia fashion, you are not doing REST, the end. You might be doing something that's cool and useful, but if you're handing back XML, if you're handing back JSON, if you're handing back anything other than a human-readable format that has links that will take you to the next thing you want to do or the next place you want to go, if you're not doing distributed hypermedia, you're not doing REST. And you know what's really interesting? What's really fascinating is, that's great, Roy. I like that you are willing to try to take back the term that you invented, because that's what we do, right? Somebody invents a term, and we go off, do something completely different, and pretend that that's what it was all along. Alan Kay, the guy who created Smalltalk, arguably the first and the original object-oriented system, quote, I invented the term object-oriented, and I can tell you Java was not what I had in mind. Okay? We like to take these terms and play with them and take them wherever we want them to go and then point to them and say, yeah, this is RESTful. That means it's good, right? This is distributed systems. This is an enterprise service bus. That makes it good. Yeah. It's like somehow it justifies what we wanted to do all along. It turns out that what we want to do is a lot more than just display hypermedia documents. We want to actually build real applications. And it turns out that this web that we've created, it's a lot more than just HTML and HTTP. It's a lot more powerful. It's time in some respects that we sort of throw off the shackles and say, all right, look, not everything in the web is about HTML. It started out that way. It started out as this vast collection of hyperlinked documents. It has moved so far beyond that. It has moved into an entirely different direction. It has evolved on its own, with all of us helping it, to the point where it's not really about that original vision anymore. It is something much, much greater than that. What we're really trying to do, in many respects, is we're trying to build something better. We're trying to build something different. But in order to understand that, in order to understand kind of where I'm going with this concept of modern web architecture, and by architecture I mean as a developer you have a set of predefined answers. That's really what a software architecture is, so that you don't have to necessarily think about what you want to do next. The architecture leads you in a direction. It's like the current in a river. If you just float, it takes you in this direction. And we want that to be in a direction that's good for us. It's the web, which means realistically that it's on the internet. There was a time when the internet and the web were two different terms, where the web could have been something that was on a personal network that wasn't connected to the internet, and the internet consisted of things that didn't involve HTTP, HTML, and web browsers. Those days are gone. At this particular point, as we talk about the Internet of Things, we are talking about your refrigerator being able to call back to the service center to say, yeah, I'm about to break down, right? Make sure that the warranty service ends before I do, right? Think about that. Do you really think Samsung has your vested interests in mind when they want to wire up your washing machine? Hell no. They want to sell how many times you run whites at high temperature in the middle of the day so they can sell that to the power company so the power company can amp their rates and Samsung gets a kickback. This is not to your benefit, all right? The Internet of Things is about bringing all of these various devices onto the web in an interconnected fashion to create this vast series of sticky things that will tangle you up. The web is a very apropos metaphor. And then modern, meaning hopefully I'm not going to have to reinvent all this stuff 5 years from now. Think about this for just a second. Imagine trying to do what you're doing today with tools from 5 years ago. Okay? Or 10 years ago, or God help us all, C++. Right? This is not, we want these things to be around for a while. This is not something that we want to just be able to reboot every so often. And because every presentation of this nature must have an obligatory COBOL joke, think about this for just a second. COBOL still caches your paycheck. Name one other system written in C++, in Perl, in any platform or language you care to name that is still running 40 years later. Name one. Maybe the COBOL guys got something right after all. Wait, that's not really a joke. COBOL sucks. Okay, there we go. One of the things that we need to be aware of is the fact that the modern web architecture has to understand that there are fallacies that everybody buys into when we start talking about distributed systems. Trust me, if you've ever tried to build a distributed system, if you've ever tried to work with a messaging system, if you've ever tried to build an RPC engine, if you've ever tried to build anything that involved one machine talking to another one, you've made one or more of these mistakes. If you're honest with yourself, you know exactly which project I'm talking about. If you're saying, no, I've never done that, seek help. You've done it. These are not mine, all right? Actually, these last two are, but the first 8 were a presentation by a guy by the name of Peter Deutsch. He actually was a Sun Fellow for a long time, and he called them the fallacies of distributed systems. The network is reliable. Okay, how many of you are staying at a hotel here in New York? You already know the network is not reliable. How many of you have ever tried to pull out your cell phone and say, oh my God, no bars? Yeah, the network is not reliable. Bandwidth is infinite. How many of you are staying at a hotel in New York? The network is secure. How many of you are in New York? Right? Topology doesn't change. The cloud is going to ruin you of this assumption very, very quickly. Right? Because as soon as Microsoft decides, you know what, we want to rearrange the servers in the cloud center, so we're going to take these machines and move them over there, and we're going to take these machines, and you know what, we'll ship them off to Boca Raton, Florida. And your stuff is just moving all over the place. You have zero control over this. The cloud really will exacerbate this if you're not careful. But administrators, transport costs, the network is homogeneous. This was actually added by James Gosling of Sun, of Java fame. And his argument was the network is not homogeneous, right? There are lots of different operating systems out there. Therefore, you should write everything in Java. Okay, Jimmy, that's a great pitch. Doesn't make any logical sense, but that's a great pitch, right? This was dead ever. I mean, you know, we're a .NET shop. No, you're not. You're a TCP/IP shop. That's what you are. That's about where the similarities end, between that machine and that machine and that machine, because the boss has an iPad and he wants one of those freaking cool MacBook Airs, and your servers are still running SQL Server, but you just partnered with another company that's running Oracle. You are not a .NET shop, okay? You're not even a C# shop, because the boss's kid, he learned VB in school, and that's what he's going to use to write that mission-critical application that dad is paying him to write, which you're going to inherit. Yeah. What we want out of this modern web architecture has a bunch of requirements, and in some cases, these will all apply. In most cases, most of these will apply. It needs to be modifiable. We need to be able to extend and grow, because otherwise, if we just say, all right, this is V1 and we're done, customer expectations, they continue to change, they continue to grow. It needs to scale, because part of, we talked about it on the panel yesterday, part of the goal for a lot of these companies, these corporations, is to take their internal systems and project them out to the edges of the company so that other people can get at that stuff directly without having to involve a human being. This is also where the whole Internet of Things is going, is in some cases meeting the company at the company border. The refrigerator reaching out to Samsung to say, hey, by the way, something bad is happening, or yeah, everything is just swimming along here, or you know, there's all of the highfalutin, yeah, your refrigerator will send you a text message when, you know, Jimmy has left the door open again. It's like, if the refrigerator knows the door open, how hard is it to put a motor on the hinge and just close the damn thing itself? Seriously, this is, you know. And then, of course, you know, there will be the lawsuit from the grandmother who was trying to get the orange juice out, and the door swung shut and, you know, broke her arm, snapped it off, she died, exsanguination, whatever, right? And by the way, if the whole Internet of Things doesn't make you start thinking about Schwarzenegger and robots, you're just not thinking it all the way through here, all right? We need it to be performant. We need it to be reliable. We need it to be recoverable. There's all of these itties that we want this modern web architecture to embrace. What I believe, and I mentioned this yesterday on the panel, what I believe we are trying to do is we are trying to build platforms. We are trying to build, from a developer perspective, the moral equivalent of what Facebook has done, of what Salesforce has done. Now, don't get me wrong, they have scalability requirements that most of us will never ever have to see. Right? Hey, if I can build a system that manages to allow 10,000 people to use it simultaneously, I'm feeling pretty good, because that's who my customer base is, that's who my employee base is, that's all of that stuff. That's where I think we're, you know, that's my goal, that's where I need to be. I don't need to build things that are that large a scale. So, what exactly does that mean? Platform-oriented development. What exactly does that drive me towards? Well, there are several different definitions of the term platform. I grabbed a couple. Computing platform, whatever pre-existing environment a piece of software is designed to run within, obeying its constraints, making use of its facilities. Meh. It's a, you know, fairly high-level definition. Typical platforms include a hardware architecture, operating system, and runtime libraries, right? Win32 is a platform. iOS is a platform. OS X is a similar but different platform. A set of subsystems and interfaces that form a common infrastructure on top of which a set of related products are developed. This is a little bit better, because notice there's this idea of common set, right? Set of subsystems, set of infrastructure. There is a unifying thread inside of a platform around the idea that we're trying to accomplish something that, particularly for those of us who don't work for Microsoft or Google or you know, any of the other big infrastructure companies, there's something domain related there, right? Salesforce is about CRM. And everything they do in their particular platform is around this concept of CRM. Now, that's a fairly big topic in of itself, but I can build a platform around much more specific things. Maybe my goal is to build a platform around gas mining. My goal is to build a platform around energy billing. My goal is to build a platform around hosting a gaming convention. I'm actually in the process of working on said application right now, said tool, said platform, specifically around being able to run a board gaming convention in Bellevue. It is a set of components, services, interfaces that are designed for developer consumption. The platform is something that developers consume, not end consumers directly. Yes, end consumers will fire up a user interface, which you or perhaps a third party, a partner, a close relative, whomever, they're using your platform to present this particular data, but the goal here is that it is driven to developers. Developers, 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 developers. Ballmer was more right than he knew, because nothing happens on the web without developers touching it. Your goal is to build something that reaches out to them to say, here is how you accomplish things. Now, the other developers, they may be you. Just like when we build libraries, you're often building libraries for yourself. It's a way of thinking about your problem. It's a way of segmenting your problem. Just up the road, the Skills Matters folks are doing the DDD conference, right? I forget what the exact name is, where they're talking about domain-driven design. The reason we build these domain objects is because we need to think about it in a particular way. We find it useful to partition things out that way. You're creating something for yourself. In some cases, you're creating a platform for your own consumption. More often than not, you're creating a platform for the consumption of other developers that aren't you. It may be another team within the same company. It may be a different company. It may be partners that you have never met in your life. But the goal is to build this thing that they can consume. And I mentioned some examples of these already. Facebook and Twitter, of course, are very popular web platforms. It doesn't mean that you're always talking about platform as a service, PaaS as an acronym. So PaaS and infrastructure as a service and software as a service, and now we've got other like authentication and authorization as a service and so on and so forth. In some cases, what these people are doing is trying to build things that will help you create a platform, but they're not a platform in of themselves. And again, as I said, it doesn't mean you have to create something for 20 million people. You can create a platform for 100 people. That is still a legitimate platform. Its user base may not be particularly big, but you will most certainly find situations where you are building an internal platform, a platform specifically for internal consumption. More often than not, though, part of the reason you want to build a platform is because you want to extend this to other companies, to partners, to people who are willing to give you money because you do something hopefully better than everybody else. Is there anybody here who does not like getting money? Smart. I was doing this talk a couple of weeks ago, and I actually had one person in the front row raise his hand, and I'm like, you don't like getting money? He's like, no. Where do you work? University of Washington. Really? And you teach for free? Well, no, that's different. Yeah, you like money, you just don't like other people getting money off of stuff that you're thinking about. Yeah, okay. Excuse me. What does this mean in practical terms? It's a couple of things, right? First and foremost, a platform is a couple of, I think, fundamental components. It starts with a communication backplane. You'll notice I don't say HTTP here. There are a lot of people who are going to stand up and say the only way to do things today is to do it over HTTP. Did you know that printers are actually communicating their status over HTTP these days? If you get like an HP printer, that the printer is actually running a small web server on the printer. And it's using HTTP to communicate its status. Everybody knows that routers are doing the same thing because that's how you administer the router to begin with. This is how you log in and say, okay, set up DHCP from these particular ranges. They're presenting you with a web browser, right? HTTP is everywhere. It feels like that's the only protocol we ever need. And quite frankly, I don't believe that. I think in many cases we reach for it because it's easy and because it's cool. Because come on, man, who doesn't want to put a web server on a printer? That's just cool. So imagine the day when your refrigerator has a web server running on it, right? And, you know, your phone already has a web server on it somewhere, I guarantee it. If not, you can download a server to put it on there because, hey, who doesn't want to issue a request to a device whose IP is constantly changing? That's just fun, man, right? HTTP is a useful protocol. Don't get me wrong. It's not the only way to do this. There are lots of different approaches, right? That's part of the reason why I'm here. There is absolutely no reason this communication backplane couldn't be a messaging product, couldn't be an enterprise service bus, could be lots of different things. You need some form of communication backplane because this is intrinsically a distributed system. This is about other parties being able to participate in your world. And part of the reason they want to do that is because you have data, in many cases, that they want to get at or that they want to contribute towards. Amazon's data is interesting for two reasons. Number one, it tells me what I want to buy. And number two, it tells Amazon what I want to buy, right? And so this is a case where I look at the Amazon database and I say, ooh, that book looks good. And then I tell Amazon that their data has changed by saying, I want to purchase that book, okay? So it's often this idea of we take data and we want to make it accessible to people. There will be smaller sets of cases where all you want to do is computation, right? And this starts to get into some of the original grid stories that came out in, you know, the late 90s, early 2000s that often got wrapped up in the whole SOAP and WSDL thing. Okay, if you want to calculate the human genome or you want to start, you know, cracking down and saving cancer and running all these weather simulations and what have you, yeah, those are going to be just pure raw calculations. But those are actually, for the most part, edge cases. 90% of what people in this room, I assert, want to do is exchange data, modify data, change the data, modify the data, change the data, modify the data, and then occasionally just look at the data. Data visualizations are becoming a big deal, right? Being able to take that data, slice it, dice it, twist it around, produce a really cool graphic that goes viral and you get rich, right? These are all the things, centers around data. Uncle Bob, I noticed in the open source magazine, says the database is not the center of your application. He's right, but it kind of misses the point because the data is really still king. We as application developers don't want to admit that because it means that the DBAs, they get, you don't have access to the data. No, that's not true either. Other people need access to that data, but they don't necessarily need access to the database, if you can see that difference. But part of the thing that comes with this is also the idea that there's a shared execution context. There's an understanding as to how these things will work. APIs are insufficient in of themselves because APIs often need to work together in some fashion. For the board gaming thing, for example, that I'm building, there's this idea that an event, somebody is running a game of Settlers of Catan at this table on this date at this time. And that is all part of this convention. And so when you access the system, it's understood that you are working with this convention. You've sort of established that as part of the shared context. And that you have, in fact, authenticated and you have the authority to manipulate that particular data. Perhaps you're the game host and you want to change the description. Perhaps you're the game host and you want to see who has signed up. You're an attendee and you want to sign up. You want to sign up, but there's not enough room, so you're going to get on the wait list, et cetera, et cetera. A lot of times, though, because so much of this is about data, we want to see some kind of data reporting. Now, again, this can be either direct visualization or it can be slicing and dicing the data to get it back to you in some particularly useful fashion. And there's usually going to be a great deal of domain-specific stuff to go with this. If you're into energy and gas mining, obviously there's going to be a bunch of things that are related to that I can't even begin to imagine because I'm not in the energy gas industry. If you are a financial accounting system, you're going to have APIs, you're going to be having data elements and so forth for being able to add to an account, create a journal voucher, et cetera, et cetera. They will all sort of fit within this world. You're creating this cohesive environment that people can consume And by people, I mean developers. Is it just a set of APIs? Yeah, sort of, because APIs are typically going to be the way to do this. But again, it's not web APIs. If you defined a messaging backplane that said, hey, I'm going to submit this message, and you're going to send this message in response, or I'm going to throw this message into the system, and all of this processing will take place, and eventually a result will happen, which I may or may not see directly. All of this is, in many respects, it is an API. The kind of messages, the types of messages you define are themselves an interface. Not necessarily an interface in the sense of what we think about in C#, not necessarily an interface in the sense of what we've thought about in terms of WSDL and Corba IDL and so forth, but it is still an interface. And some interfaces are deliberately designed to be more extensible than others. Modifiable, versionable, open-ended, weakly typed, all of these other great terms. But it's not just a set of APIs. There's this other idea that there's this shared infrastructure, and quite frankly, the platform isn't always about developer infrastructure, right? To simply stand up and say, yeah, we're just going to create a set of APIs, boom, off you go. Well, these need to be really domain-centric. They need to be domain-focused. If you're Salesforce, they need to be around the concept of CRM. They need to be about CRM, because that's what they really do. That's what that platform is about. And they have to have this idea of a known context, execution environment, et cetera. You're building something around Salesforce. Salesforce has a series of APIs there. They have a series of environments there. There's this notion of, well, this particular type of customer is owned by this particular type of company. And that's understood. It may not be something that's directly expressed by the APIs. If I modify this customer, does that mean that the company at which that customer